Hey everybody, so in this video we're going to talk about section 8.4, more operations on fractions, and specifically we're going to talk about compound or what's sometimes called complex fractions. Okay, so the first thing we want to do is say what is a compound or complex fraction? Okay, so a compound fraction or a complex fraction is a fraction where the numerator, the denominator, or both contain a fraction themselves, okay? So an example might be 1 plus 1/2 over 3. Okay, this is an example of a compound fraction because the numerator contains a fraction. You also might have something like 5 over 3/2. Okay, because the denominator of this contains a fraction, or you might have something where they both contain a fraction, like 1 plus 1 over x over 1 minus 1 over x, okay? So these are all examples of compound fractions because you have a fraction within a fraction, okay? I like the notation compound fraction because it makes more sense to me than complex fraction because complex implies something about complex numbers, right? Where compound doesn't have that same connotation. Okay, so what we're going to focus on is simplifying these fractions. Okay, so this goes for whether you're looking at a numerical compound fraction like these two or something that has variables like this one. This method will always work. Okay, so the first step is to find the LCD of the small fractions. Okay, and what I mean by that is the like inner fractions. So here I would be talking about 1/2, here I'd be talking about 3/2, and here I'd be talking about the 1 over x. Okay, so you find the LCD of those, then you multiply in the numerator and the denominator. Of the big fraction by that LCD. Okay, then you're going to simplify. Okay, and you should have no more compound fraction. Okay, all right, so let's see some examples. Okay, so now when we're looking at this, there's only one small fraction. It's just the 4 over x. So the LCD that we're talking about is the LCD of 4 over x, which is obviously just x. Okay, so when there's only one small fraction like this, you're just using the denominator from that fraction. Okay, so I'm going to multiply by x over x. Okay, and I'm distributing this. So x times x is x squared. X times -2 is -2x. Okay, then I'm distributing here, right? X times x is x squared, right? And then we're thinking about -4 over x times x, right? Now these are going to cancel and just leave me with -4. And that's the point of using the LCD here, is that you're canceling these denominators. Okay, so when these cancel, I get -4. Okay, so you can see after that step that I really don't have any compound fraction anymore. I just have a normal rational expression. So I'm going to continue simplifying this by factoring. I can see that I have a common factor of x. So when I factor that out, I get x minus 2. And in the denominator, I have a difference of squares. So this is going to be x plus 2 times x minus 2. Now I can cancel my common x minus 2 factor, and that will leave me with x over x plus 2. Okay, so using this LCD clearing method, it allows me to rewrite this as a normal rational expression, and then I can simplify it the way we did in section 8.3. Okay, let's see another example like this. Okay, now when we're talking about the smaller fractions here, we can see that the denominators are a, 2a, and a. So my LCD is going to be 2a. Okay, so I'm going to multiply here by a over, 2a over 2a. Okay, now I'm going to write this out so that we can really see how this is going to work. So I have 2 over a times 2a plus 3 over 2a times 2a, okay, in the numerator. Okay, and then in the denominator, I have 5 times 2a plus 1 over a times 2a. Okay, now here, this a is going to cancel with this one, okay, and I'm going to be left with 2 times 2, which is 4. Okay, here this 2a is going to cancel with this 2a, and I get 3. Okay, in the denominator here, there's nothing to cancel, so 5 times 2a is 10a. Okay, and here this a cancels with this one, so I just get 1 times 2, or 2. Okay, now these are not like terms, so I can't add them together, but I certainly can add 4 and 3 together to give me 7 over 10a plus 2. Okay, and that would be my final answer. Okay, now sometimes students are wondering, how did I get all these little 2a's? That's from distributing this 2a to each term in the numerator and each term in the denominator. Okay, just like we did up here, right? I just decided to write it out so that we can really see how things are canceling here. All right, let's see another example. Okay, so when we look at the two smaller fractions, we have x over y and 1 over y. So it's clear that the LCD is going to be y. Okay, so I'm going to multiply by y over y here. Now when I distribute this, I get x times y, or xy. Okay, and then here, this y is going to cancel with the denominator, so I just get x. Okay. In the denominator here, I get 1 times y, or y, And here I get 1 over y times y, which is 1. Okay. Now I can continue simplifying by factoring out an x in the numerator. Okay. My y plus 1 factors cancel, and my answer is just x. Okay. So you can see that these really do simplify quite a bit. Okay, let's do one more example of this because this is a pretty common type of example. Okay, this format where you have a constant over 1 minus x is kind of something that you see a lot in applications. Okay, so because we only have one denominator, we can see that the LCD is just going to be x. Okay, so I'm going to be multiplying by x over x. Now here 1 times x is just x. Okay, in the denominator I'm going to distribute, so 1 times x is x. X times 1 over x is 1. Okay, so I'm going to get x over x minus 1. Okay, now you can't cancel anything here, so this is my final answer. Okay, not as complicated maybe as some of the other ones, but it is something that comes up a lot. Okay, let's look at one last example of this process. Okay, now we have 1 over x and 1 over x squared. So my LCD is going to be x squared. Okay, so I'm multiplying by x squared over x squared. Okay, and this time again, because I have some more complicated stuff going on, I'm going to go ahead and write out what I mean. So I'm going to get 1 times x squared plus 2 over x times x squared in the numerator. Okay, and then in the denominator, I have 1 times x squared minus 4 over x squared times x squared. Okay. Now in this first term, there's nothing to cancel. It's just 1 times x squared, so I get x squared. Here, this x cancels with one of these. Okay, so I get 2 times x, or 2x. Okay. In the denominator, okay, I'm getting, here I have x squared, okay, and this x squared is going to cancel with this one, so I just get minus 4, okay. I can factor this, so I see that these two have a common factor of x. Okay, and here this is the difference of squares, so I get x plus 2, x minus 2. Okay, so I can see my common factor of x minus 2. I'm going to cancel that, and I'm left with x over x plus 2. Okay. Now, if this looks familiar, this part and then the answer, that's because it is the same thing that we got for a previous example. Okay, we got the same answer for the very first one that we looked at, x squared minus 2x over x squared plus 4, and simplified it to x over x plus 2. Okay, but you can see that the starting questions actually look different. Okay, so this is just showing you that even two different looking examples can have really similar process and even the same answer. Okay, all right. I hope that makes sense, and I will see you guys soon.